Welcome to the Starter Essential video tutorial on MESYS Shaft Calculation module. Over the next few minutes, you'll discover how the software transforms geometry and load data into insights on strength, stiffness, bearing life, and critical frequencies. Powerful knowledge that can drive confident mechanical design decisions. So, let's start on the System Inputs page. In this section, alongside entering the project title, you can define the global modeling options. Typical quick start selections include angle for weight that aligns gravity with the shaft's actual orientation, natural frequency analysis to detect critical speeds early, load spectrum mode for cumulative fatigue evaluation, or housing temperature and material out of an extendable database can also be specified here. Lubrication settings that apply to all components of your simulation. Display settings, for instance 3D cutaway mode, can be given under this tab. Under the Shafts tab, each shaft is assigned a name, material, an axial position, rotational speed, and operating temperature. If a strength verification according to DIN 743 is required, the corresponding settings are also entered in this area. Geometry can be defined either using a classical matrix input or by sketching a quick polyline profile, optionally on top of an imported background drawing. A shaft system can be imported in several formats, including REXS. A shaft geometry can be brought in as a step or DXF format. Under the Loading tab, a whole world of load types opens up. A toolbar lets you add point forces, eccentric forces, harmonic excitations as dynamic force, unbalanced masses, pulleys, and complete gear connections. In the Support section, you can add rolling bearings, which link directly to the MESYS rolling bearing calculation module. Here, each bearing can be entered with a basic connection or analyzed with the extended calculation module. Further options at your disposal include plain bearings, weld connections, general constraints for all 6 degrees of freedom, cylindrical supports, coupling for reaction torque, or arbitrary 6x6 stiffness and damping matrices, ideal when housing compliances are available. In the Sections tab, you can define multiple DIN 743 compliant cross-sections and specify any associated notch details. The Documentation Point section type also offers a Calculate Stiffness option, very useful, for instance, when you need to verify spindle nose stiffness. On the Settings tab, you fine-tune model fidelity in seconds, apply temperature profiles, enable 3D cutaway views, tweak strength calculation options, and let geometry variations participate in parameter studies, all with just a few clicks. The Results overview at the bottom of the window displays the key outputs. Configure the content of this overview under Menu Extras Results Overview. The Shafts tab collects the global results for every shaft in the system, and it is always only a few clicks away from your current view. The bearing table condenses every rolling bearing in the model onto a single screen. For each row, you can read values for bearing life, contact pressure, radial and axial loads, displacements and misalignments, and many other parameters more, selectable via the context menu. The frequencies table gathers the entire model signature of your shaft system. Each row lists a natural mode with its frequency in Hertz, the equivalent RPM, and type of mode. You can print natural frequencies with the main report or via critical frequencies report. Additional entries in System Tree allow you to group multiple shafts, position them in space, link gear stages, and even embed fully 3D elastic housings or planet carriers. When it comes to analysis, The calculation menu provides tools for parameter studies, so you can investigate, for example, which axial clearance is optimal or how ranges of temperature and speed influence system behavior. Minimization and maximization routines are available to identify limit values on the specified constraints. Load spectra can likewise be defined and combined with these studies, enabling a single input file to cover worst-case, nominal, and fatigue scenarios side by side. The report command produces a complete results document, and report options lets you choose the template, output format, language or units, and which table or graphics to include. In addition to the main report, individual bearing calculation reports can be generated via the context menu of each bearing entry. The result table's export collects all numeric outputs, shafts, sections, bearings, into dedicated tables that you can freely reuse in other applications, for example in spreadsheets or post-processing tools. The graphics area offers numerous predefined plots like forces, moments, or stresses, and 3D views for instant visual insight. The Campbell diagram, a speed versus frequency map that reveals where excitation orders intersect natural modes, making critical speeds impossible to miss. Bearing overviews with color-coded grids that display at a glance each bearing's load distribution, contact stress, and roller profile or load. The 3D geometry can be shown without or with exaggerated deformations. The representations are available for the whole systems and for each group, making it easy to visualize overall layout or highlight critical deflections. Several graphics can be exported as step file through the Graphics CAD menu. At this point, we'd like to thank you for your attention. Hopefully, this tutorial has given you a solid impression of the value MESYS can offer, and we look forward to welcoming you again in a future session.